How you doing, guys? This is Joe with LVV. I'm sorry about the midway through video, but I'm just going to explain and catch you up to exactly what I found here. Customer says that the heat's not running. Okay, I go downstairs. I see that there's a transformer that has it's a popper transformer. Okay, where I think it gets like 3 amps and it pops. So the way you can test a transformer and see how much voltage should be going through that, or amps going through that, is you're going to take it's a 50 VA transformer, and you should take the 24 volts, divide that into the 50 VA, and then you'll get more or less right around 2 amps. That's what you should be running through, okay? A transformer that size. So you take the 24 volts, divide that into the VA, the 50, and you should more or less get around 2 volts, nothing more than that. That's why it pops around, I think it's like 3. Anyway, so I reset it, heat turns on, no problem. All right, shut it down, put the AC on, and all of a sudden my board light starts going crazy, starts flickering, and then all of a sudden it pops. So I come outside, okay? I come outside to this backyard with the generator and a couple units here, and I find this, okay? I find this contactor. I pull off the low voltage, okay, onto the coil, and then I turn the unit back on, AC blower goes on, everything is fine. So once I put this back together, I'm sure it's going to pop again. What I'm going to do though is I'm going to change out the contactor, because the low voltage on the transformer is popping, so it's nothing on the high voltage making the circuit breaker pop on the inside. It's all about the low voltage here. All right, so there's probably something up with the coil, all right, because I got 24 volts from this wire here to that wire there, nothing abnormal. So I'm going to change out the contactor, and I'll continue the video and show you exactly what's going on. All right, so normally probably there's something up with that coil. It's probably shorting out, and something's going on. All right, so let me change it up, and then I'll continue the video. All right, guys, so just want to bring this out real quick. I go to the circuit breaker box. It's got 4 circuits, 3 of them on, 1's off. I had to find out which unit this was, so I turned on all the thermostats on the house, except for the one downstairs. This one went on. This one went on. That one went on. This one did not. All 3 were on. The one that I'm having a problem with is most likely this one here, and that one's off. So somebody was here, knew it was a problem, shut the breaker down, and didn't tell the homeowner, or the homeowner didn't tell me. So I think they didn't know, maybe it was the contactor. We'll dive into it a little bit more. I just wanted to show you this, what some people do. All right, guys, so we changed the contactor. I'm just downstairs real quick. We're running low amps, which is great. This is the transformer that kept on popping. I'm gonna have to fix this up. Look what these people do. Whoever here was here before, really a mechanic. My teacher back in BOCES always said to me, he goes, Joe, you could be a mechanic or a mechanic. A mechanic does things half-ass, halfway. A mechanic does things the right way. So they had an issue with the old transformer. Okay, so instead of taking that out and replacing it with this one here, you know, swapping them, taking it out and putting that there. I understand it's bigger, but I'm sure we can get a screw in there. All right, somewhere to lock it in. If we can't, you know, I could put it to the side here or to the side there. Not so that it's just hanging out over here like this. So at the same time, no wire nuts. So I'm gonna have to wire nut these up, mount that safely, okay? And it was the contactor. So the coil on either side was giving an issue, okay? Because had way too much amperage coming through. That light was going crazy, and then it would pop this little 3.2 amps, okay? And like I said, you have 50 VA. See in the bottom right hand corner, 50 VA, 24 volts. So you divide the 24 into that 50, which you shouldn't have more than, say, 2 amps going through this. That's why it's going to pop right at 3.2. All right, and it protects the board and it protects the transformer. So if you ever want to know how much amps can go through a transformer, just take the secondary, right, the low voltage, by the VA. So if it was 40, it would be less than 2 amps. If it's 60, it's going to be almost 3 amps before, that should be the maximum before it's going to pop, okay? On this one here, it's 24 volts. Divide that by the 50 VA and it gives you around 2 amps, which this was, you know, 0.60 while everything was running, even the heat. Okay, so so that was the issue. We're gonna change it all up, and I'll just give you a little shot when it's all tied up, so to see how we at LVV tie things up and make sure that everything looks good. All right, guys. So our job is done here. We got rid of the old transformer, which was doing nothing, was burnt out. We installed and actually reinstalled this 3.2 amp 50 VA transformer. We put wire nuts on every single wire. Got rid of all of the black tape that's over there, and we zipped it up nice so that it's out of the way and it looks nice. It's the way it's supposed to be. Okay. All right, guys. Well, have a good Thanksgiving. Hope you're all being safe with your families, and if you like, subscribe, and I'll keep throwing out these videos. Have a good one, guys.